Now I'll discuss with you the change of order of integration. Here the limits of integration for x and y are constants, then in that case you can evaluate the value of this double integral fxy dx dy in either order. That means you either integrate with respect to x first or with respect to y, so that will be the same only. You can do that one without changing the limits of integration, because the limits of integration for both x and y are constant. However, if the given double integral has a limits for y as function of x, then but we need to find out evaluate this double integral whereas by changing the order of integration. Then in this case, what we need to do is we need to find out the new limits of x now as function of y. The original one is given to be the limits of y in terms of x, but to change the order of integration, we need to find out the new limit of x now in terms of y while changing the order of integration. And this is usually best obtained from geometrical consideration. For this one, to obtain the new limits of x in terms of y, what you have to do is you have to draw the graph of those limits of function given for x and y, and then from the graph or from the figure you can find out the new limits of integration for y in terms of constant and for x in terms of y. So let us come to this problem now so that it will be more clear to you. Change the order of integration in the double integral 0 to twice a integral square root of twice a x minus x square twice a x fxy dx dy. Here we don't need to evaluate the value of this double integral. We just have to change the order of integration. Now, according to this given question here, the limit of integration for x is this one. X varies from 0 to x is equal to twice a, and for y it is this one. Y is equal to square twice a x minus x square to this one. The upper limit is y is equal to square twice a x. So you can denote the upper limit or lower limit by as equation 1 and this as equation 2. Now let us simplify this equation 1. On simplifying equation 1, you'll see that by squaring both sides, we'll have y square is equal to twice a x minus x square. Transfer this 2 to this side, then you'll get x square plus y square minus twice a x is equal to 0. Or when you add a square on add and subtract a square, then you can express this equation now as x minus a the whole square plus y square is equal to a square. So now this one actually represents the equation of the circle centered at a0 and of radius a. Now from the upper limit y is equal to square twice ax, you can find out what is y square. Y square is equal to twice ax. So this one you can plot the points here in this table. When x is equal to 0, y will become 0. When x is equal to twice a, so it will become 2a into 2a will become 4a square. So y square will be plus or minus 2a. And this represents a parabola. So first of all, let us draw the graph of this one. X minus a the whole square plus y square is equal to a square will represent a circle centered at a0 and of radius a. So this is a here. So in this case, it will be like this. So this is a circle centered at this one. So now here what we need to find now next step, what we need to do is we need to draw the graph of this one. Y square is equal to twice ax. So you can see this one, when x is equal to 0, y is equal to 0. When x is equal to twice a, y is equal to either plus or minus twice a. So it will be here and this one. So you'll see that. So it represents a parabola. So this one is y square is equal to 2ax, and this one is that x minus a the whole square plus y square is equal to a square. Now next step, what are the given let us find out what are the given limits for x. The given limits for x are x is equal to 0 to x is equal to twice a. So x is equal to 0, it will represent this one only, the y-axis. So this is x is equal to 0, and x is equal to twice a is nothing but it is a straight line which passes through x is equal to a. So this is x is equal to a. So now this one, you see that we have to find out the new limit now for x in this region enclosed by this one, and lying between this circle here and this one. So here, since we are considering only y, I omit this one, the the portion which lies below the x-axis, because y here in the question is given to be squared twice ax, which lies above the x-axis, that is this one. Y is called square twice ax, so it will be only this portion. Now to obtain this one, what you need to do now, you can draw the graph of the, sorry, not the graph, you can draw a line which passes through x is equal to a. So when you draw this one, actually a will be here, then it will be a straight line like this. Okay. So this is x is equal to a. Now next step, what we need to find is, now we need to find out a new limit of integration. So that region will be this part here, this region here, plus this one and plus this one. So I can denote this one, this region here will be region A, and this region here will be region B, and this will be the region C. Okay. So to find out the new limits of integration, we have to split this one, this region here, into two subregions A, B and C. So now you can see here what will be the limit of integration now. Here this is y is equal to 0. Sorry, I made a mistake here. This is y is equal to A. So for this region here, or subregion A here, the limit of integration for y now will be from y is equal to 0 to y is equal to A. And for x it will be, because this green curve here is represented by the parabola y is equal to square twice ax. So the low, now let us find out what will be the new limit for x. It will be this one. From this equation you will get x is equal to y square by 2a. So this will be the limit of integration for x. The lower limit will be this one, and the upper limit here, which is on the right side. Now the right side, it is bounded by the circle. So from this equation, x square minus x minus a whole square plus y square is equal to a square. You can find out what will be x minus a. It will be a square minus y square. You can take the square, positive square root. X is equal to a plus square root of a square minus y square. So the lower limit will be this one. Not the lower limit, the upper limit, it will be this one. X is equal to a plus square root of a square minus y square. So here the original integral, x is equal to 0 to x is equal to twice a, y is equal to that one square root twice a x minus x square, to y is equal to square root of twice a x fx y dx dy. Now has to be split into three subregions, a double integral for this three subregions, so that we can find out the new limits of integration. Now for y it will be, now for the first part, that is for this region A here, it will be y is equal to 0 to y is equal to a. And for x you have to take out the lower limit is from the left only. This region is bounded from the left by this curve, so it will be x is equal to y square by 2a. 2, now x is equal to this one, a plus square root of a square minus y square fxy dx dy, plus now it will be this region B. Let us find out this. In this region B again, y varies from 0 to a, because it is bounded below by y is equal to 0 and above by this line, which is y is equal to a. And on the left it is bounded by this circle, so it will be integral a plus square root, because x is equal to this one, a square minus y square, and to the right, see, to the right it is bounded by the line x is equal to 2a, so it will be x is equal to 2a fxy dx dy, plus now the last one will be this one, this region C here. This region C here, you can see that the point of intersection of this parabola with x is equal to 2a is x is equal to a. So here that means y will vary from y is equal to a to y is equal to this one, y is equal to 2a. So the limit of integration for that region C here will be y is equal to a to y is equal to 2a. And for x, you can see on the left side it is bounded by this curve that is represented by x minus represented by this one, y square is equal to twice ax, but for now you express x in terms of y, it will be x is equal to y square by 2a, so it will be x is equal to y square by 2a to y is equal to what? To x is equal to what? On the right again it is bounded by the line x is equal to 2a. So it will be x is equal to a fxy dx dy. So now you see that the original double integral where x varies from 0 to twice a and y varies from square root twice ax minus x squared to y is equal to square root twice ax fxy dx dy. When you change the order of integration, that means find out the new limits for x in terms of constant and for x in terms of y, then you'll get 3 double integrals here for 3 sub-regions. For region A, you can see that y varies from 0 to a and x varies from, because on the left it is bounded by the parabola y square is equal to twice ax, for which x can be expressed as y square by twice a, and to the right it is bounded by this circumference of the circle, which is represented by the equation x minus a whole square plus y square is equal to a square, and on simplifying this one you'll get the value of x as a plus square root of a square minus y square. So that will be for region A. And for region B, you can see that again it is bounded below by y is equal to 0, that is the x-axis, and above it is bounded by the line y is equal to a. Then the limit of integration for y will be from 0 to a, and for x it will be, since on the left it is bounded by the circumference of the circle, for which x has been expressed as a plus square root of a square minus y square, and to the right it is bounded by the line x is equal to 2a. So the upper limit will be this one. And for this region C, it is this one. So on the left, you see that here y varies from a to y is equal to twice a. And the limit of integration for x will be, because on the left side it is bounded by the curve of the parabola represented by x is equal to y square by 2a. So the lower limit for x will be this one, and for the upper limit will be this one, because it is bounded to the right by x is equal to 2a. So this will be the way of changing the order of integration while finding the new limits of integration.